All right, good evening, everybody. So we're going to be going over questions regarding graphs, and then we're going to do a review of a interview question that ultimately uses hash tables called the longest common longest increasing sequence problem. And we're also going to do one from Lead Code that's for graphs, where it's doing a curriculum scheduling. But first, what I would like to do is I'd like to introduce Billy Porter. Billy is this week's guest speaker, and you were in my class last spring, right?
Yes.
Yeah. So Billy, in the summer, he was a Google STEP intern, and so Billy's been gracious enough to come in and speak about his experience. And then after that, I'll give you all the opportunity to ask him some questions about his experience on that. So Billy, I'm going to post your video, in your video here, and get out of the way and let you go.
Great. Thank you. Yeah, so I thought first I'd start and just talk about kind of my experience as a Google intern, what that looked like, what the STEP program is, before just giving some like general application advice, as well as like, how you can, get some internships. So yeah, I was a Google STEP intern this last summer. And STEP, for those of you who aren't aware, it's basically like Google has their software engineering internship, but that's pretty much for juniors only. So they have this first and second year one, so freshmen and sophomores program, and you essentially do the same things, just with more, host mentorship, a little more leniency. You're working in with pairs rather than working solo. So it's a great opportunity for a first internship. It's primarily targeted at underrepresented minorities in tech, so girls, blacks, Hispanics, definitely. But there are definitely like exceptions made. So if you don't belong to one of those groups, don't be discouraged to apply. Yeah, so I applied last year around end of September. I got my interview not until right after New Year's. It consisted of 2 technical interviews. They weren't too bad, and a lot of the questions you're learning here will more than prepare you for those interviews. And then with Google, how it works is after you get and accept the offer, you enter a phase called host matching, where you fill out a project questionnaire and they match you based on what host, like your feedback, like your resume, and what interest you identified. So I was matched with a machine learning team doing targeted advertising, which is super cool. But unfortunately, due to the coronavirus situation, they took everyone off of their teams, and I just had a remote internship, not on a team. I was still on a team for meetings and such, but we just worked on our own stuff. So essentially what my program was, we had a 6-week like web development course, and then we had 6 weeks to create our own website. We worked in a pod of 3 people. So we created this website called Gmapper, which essentially was a snapshot in history built with an Angular framework, and users could query a city and then see historical photos information. There's a video to that on my YouTube, but they did take the website down, so it's no longer live. And the reason why I'm just talking about the remote experience was because I talked to a Google recruiter last week, and I'm pretty sure the internship's going to be remote again this summer. So if anyone's Google STEP, just know that, or wants to work at Google, just know the remote experience is great. They sent you monitors, they sent you computers. They did everything they could to make sure the remote experience was good. I would have loved to be in the Google office, but yeah, fingers crossed for next summer. Yeah, so those kind of experiences, Google intern. The hosts were definitely really receptive. I definitely strongly recommend trying to intern at a big company for one of your first internships. It's just more structured. Google's not going anywhere, and the host, the errors you're making aren't super critical, so everyone is very constructive for you. As for some general, internship prep and like interview advice, before you can ask some questions about either, what I just want to say is there are some misconceptions with applying to internships. For example, something I always heard, especially heading into my sophomore year last year, was the hardest part of this was going to be passing the interviews. And that, I should spend a lot of my time studying these interviews. You look online, everyone's talking about Lead Code and Hacker Rank and how you need to grind through all of them. And while you definitely need to learn the interview skills, I found that the hardest part is getting the interviews in the first place. Last year, I went into the year and, I was so confident. I had this great resume. I had a great GPA. I thought all I had to do was get really great at these technical interviews, and then I could, kind of choose the company I wanted to internship at. Surprisingly, Google was actually the only company that gave me an interview. I applied over 60 companies and I only got an interview with Google. So that was super fortunate, but I just easily could have ended up without an internship. And so this year, applications came and I thought, well, I have Google on my resume. Resume is even a little better. I'll pass, the automated resume scanners. And yeah, I've still been, pretty low on luck with interviews. So how do you get interviews in the first place? Well, I strongly recommend, and I just want to point out that these companies are getting, loads of applicants. Google gets over 100,000 a year. Citadel, which not many of you have heard of, but it's a quant firm, they get over 40,000 a year, and there aren't a lot of internship spots. And a lot of these recruiters, they won't even end up reading your resume just because they're just such a high volume of applicants. So last year when I was applying, yeah, I had a great resume, but was my, resume even being read? Who knows? So some things you can get around that with are apply as early as possible. Google STEP just opened, I think either yesterday or Tuesday. All these companies function on a rolling basis. So if they're going to, start going through random applicants, they're going to start at the top. But beyond that, and much more important than that is, and I know it sounds cliche, but you have to network. You look at a company you want to internship at or intern at, you need to go through LinkedIn. You need to see what Notre Dame alumni are working at these companies. There aren't a lot of them, but pretty much every company I've been trying to intern at, there's Notre Dame alumni working there. And so you can message them on LinkedIn, exchange a few back and forths before setting up a call, and ultimately ask for referral. More often than not, these alumni really want to give you referrals, and it doesn't have to be Notre Dame alumni. You can reach out to anyone who works at the company, but that's a pretty big must for, trying to get an internship. I can't tell you how many times, for example, I'm applying to a company, I apply, I hear nothing for weeks. All of a sudden, I'm talking to alumni, he gives me a referral. All of a sudden, the next day I get a coding test. These referrals really work. They work less so at companies like Google, Microsoft, Facebook, Amazon. They're just such big companies that so many people get referrals. The referrals don't matter much. In fact, this recruitment cycle, the Microsoft referrals, like they released an internal memo, then referrals don't even matter. But, the mid-sized companies, like you're looking at Lyft, Uber, other unicorns, and really anything smaller than that, referrals are pretty huge. They can really fast track you. They can even make it so if you don't pass, some technicals, you could even get past that. And whether that's right or wrong, it's just how it is. And we kind of have to play into that system. Now, last thing, just about interviews. It's really important that you are doing a lot of practice. There are essentially 3 types of questions you can get. There's, what you would call easy questions. And those are ones you could do now without, just having fun comp experience, just, being a decent coder. Things like, finding the second largest integer in an array. Something you definitely know how to do. And then there's medium ones. And medium ones, you have to utilize, some sort of data structure. And a very common misconception is you may think that, I'm a really smart student, I understand this data structure's content really well. I know all the time complexities, I know how to use each one. I think I'll be fine once I get to the interview. Well, the thing is, all these questions, they're all kind of made up of the same techniques you have to learn. They're all, even though each question is different, the sub-problems are the same. Things like using sets for O1 access, just little things that, you start to do a lot of problems, you start to really get the solution. And, the important thing is that when you're doing problems, you really got to make sure you understand the solution. It's not just practice coding, but it's looking at the technique that the, person used to solve it and then applying that technique somewhere else. So those are the medium questions, and the hard questions are basically like you have to do a lot of those, and then plus it's you have to be super knowledgeable about the content. So that's kind of all I had. I encourage you to check out that video. I'm not sure if Dr. Morrison put it in the chat, but yeah, any questions would be great.
All right. Thank you, Billy. So I'll also monitor the chat, but does anybody have any questions right now?
I had a quick question.
Go ahead, Ashley.
You talked about like connecting and like networking on LinkedIn and asking some ND alum for referrals. How do you kind of go about that if like you barely know them and they barely know you type thing?
Yeah, definitely. So it can seem like a super awkward process, especially like asking for a referral to a company that they've worked at, for any amount of time. Generally, the approach I found that works is if you send like a connection request, you can personalize it, so you don't need LinkedIn Premium to message anyone. You can personalize the connection request, and I tend to say just like introduce myself, like, but keep it short. So like, hey, I'm Billy. I noticed you work at company X, which I'm super interested in. Would you mind taking some time to like give me a little information about the company, or like would you mind answering some of my questions? So usually they respond and they're like, yeah, like fellow domer, I'd love to answer some of your questions. So you engage a little back and forth on LinkedIn. Make sure like you read up on the company and like seems like you're genuinely interested in. It's great to then like, it's a natural progression to like set up a call, so you want to hear a little bit more. And then, yeah, it may feel a little weird. You may be a little nervous to end up asking for a referral. So the way I like to do it is in like, just the easiest way possible. Just say like, hey, do you mind if I send you my resume? Would you consider giving me a referral? Like, seriously, no big deal. If you're not willing to, so just like give it completely, like throw the ball in their court. But yeah, definitely after you have that back and forth, you should try to ask for a referral. It feels weird, but I find that I send it and then all of a sudden the alumni responds and they're thrilled to give the referral, and then just keep talking about the company. So yeah, hope that answered your question.
Yeah, it did. Thank you.
So I'm going to add a follow-up to that. So Billy gave a lot of really good advice. The other thing with regards to reaching out to people who work for a company is write something in that email or message in LinkedIn that's personal to them, not just, okay, you're at Google or you're at Microsoft, or but add something that you have actually read their LinkedIn page and understand what it is that they're doing. Because I can say this just from being a faculty, we get emails from people all over the world wanting to go work in the lab, and you can tell they just copied and pasted it. So if you actually personalize it, it sticks out like a sore thumb. You just say, "How so-and-so, I'm interested in applying to Google. I see that you are currently working there as a machine learning architect. I'd like to know more about that. Is there possibly some time that you have over the next couple of weeks? You can have a phone call or a Zoom chat, and squeaky wheel gets the grease. Send several if you're really interested in working for a company. It's kind of like for those of you here for Kyle Duffy's. That's how he got involved with his. That's how he got his internship. He reached out to a lot of people, and they eventually they knew who he was, and that makes you different than somebody who's just in the resume pile. And so, yeah, like referrals are, it's places like Microsoft, it's harder and harder to get referrals through. But at the same time, if a specific hiring group knows who you are and is familiar with your work, then that makes them much more likely to want to bring you in for an interview than if you're just sending resumes, and it puts a personal touch on it. Okay, does anybody else have another question? All right, so I put Billy's email in the chat. If you would like to, if you think of anything later on and want to reach out to him, Billy's very friendly. He's an awesome student in my data structures class last semester, and I'm sure that you'll all be very cordial in helping with each other. So, Billy, thank you for your time. You gave us a lot of really good insight into the Google STEP program. And if you all have need recommendation, please feel free to reach out to me. I'm happy to help on that front as well.
Yeah, definitely. Thank you, Professor. Good luck with the semester.
You have a good one. Hey, yeah, so Jason, okay, so Billy is gone. All right, so let me share the screen here. And so it's almost as if he knew that we were going to do some questions like that. So the first question I want to do is a kind of a common graph interview question called course schedule. And so the general idea is that you have a total number of courses that you have to take labeled from 0 to num courses minus 1. And just like we would do in any, when you're trying to plan out your classes, some courses may have prerequisites. So if I have these 3 pairs, I would have 0 is a prerequisite for 1. I have 3, that's a prerequisite for 4. We could have 7, that's a prerequisite for 12. So there's 2 challenges that we need to come up with, which is what is the most efficient way possible to develop a flow that you can actually get through your curriculum in time. So, we all pay a lot of tuition. You want people to have to stick around for 6, 7 years. We want to come up to be as efficient as possible. And the other thing we need to be checking for is if there are any classes that can't be reached. Have we unintentionally made it such that we cannot reach a specific course and you can't possibly meet the prerequisites? Ultimately, next week we're going to learn about something called a disjoint set, where we have multiple graphs in the same data structure that are not connected. But in this scenario, we would want any possible class to be reached by any possible student through a set of prerequisites. So as you saw, when I was starting to draw everything out, we had 1 maybe is a prerequisite of 3, but 1 can also be a prerequisite for 4. So as we know, fun comp, right? That's a prerequisite for data structures, but it's now a prerequisite for logic design. So the question is, if you wanted to set this up, how could you make this as efficient as possible and kind of reduce the complexity of a chart flow so you can help advise students. Students can see how well they're progressing along in the curriculum. And so what I would recommend on this front, so we've already learned enough about graphs to solve this problem. So first I would recommend the data structure would be a graph. And then we've learned about depth first search. And we also learned about this idea of topological sorting. And so with topological sorting, you get the flow of a depth first search to be able to figure out what's the flow from one class to another. So if I want to get to algorithms, I have to start with fun comp, then I have to take data structures, and then I have to take algorithms. I don't want my chart to go, well, data structures, then do discrete, like so, in the event that discrete and data structure are prerequisites, we could figure out a flow that ensures, actually this would be a better, how can we say like, okay, I can split this up in different semesters to make sure that I can progress well. So we know that we have a prerequisite, and we know that is a course that relies on a prerequisite. So if we know this, we know that we have some sort of piece of information and then a path to another piece of information. We know that a course can be a prerequisite for multiple classes. So you have fun comp, then we have data structures and logic design. So the question is, what are the paths, what's the quickest path we can get to any class? And since we can have courses be prerequisites for multiple things, this takes away, we would not want to do a linked list, and we definitely don't want to use a vector. In order to keep that, this eliminates things like hash tables, but now what we want to do is if we're trying to connect this, we're going to say we can use a graph, but in order to get this the most efficient way, I propose doing a depth first search. So in the last 2 lectures, we've developed a portion of a graph. And so the graph that we've developed in the last 2 lectures is going to be the graph that I'm going to use in solving this problem. So what I'm going to do is that shouldn't say minimum spanning tree, that should say topological sort. My apologies. Minimum spanning tree is Friday stuff. So topological sort means that we would be running depth first search, but being able to find all of the solutions. So the first example I'm going to show you is this particular prerequisite chart. And we have something here where I have a prerequisite flow, 1 to 6, but I also could have a flow 3, 5, 7. And as a test, I have 2 courses, 8 and 9, that are disjoint from the rest of the graph. So what we should be able to find is a reduced graph that tells me how to get to all these courses as best as possible. But I also should be able to tell that there's no way to get to 8 and 9. Or specifically, I know that the path to 9 would be 8. But there is no existing path from like a fundamentals course to these classes. So what I'm going to do is I'm going to first add all the vertices. So in this particular courses.cpp, let me zoom in here. What I've done first is I've identified that the data structure that I want to use is a graph. And then in the particular test case, I have 10 vertices that I'm adding. So this initializes the adjacency list representation, but we don't have any edges yet. So that's what's going to be in the next set of steps here. So I have 0 to 1, 0 to 3, and 0 to 4. And if we look at the previous chart, we see that, I'm sorry, the previous graph, we have 0 to 1, 0 to 3, and 0 to 4. We also notice that there's, some sort of edge here, 1 to 3. So we have to actually see how this will work out. Now, this is why we want to use depth first search instead of what we're going to learn about on Friday, breadth first search, because I'll say 0 to 1, and 1 is actually going to have a path from 1 to 3. And that's good because then we don't unintentionally get this edge in here. So we can make sure that we maintain the integrity of the actual prerequisite flow. If we were doing breadth first search, that would fall apart like so. So what this allows us to do is recognize when we have prerequisites, if we say 0 and 1 are both prerequisites, this removes that from the graph, which allows us to get our most efficient flow. So we add all the edges that are in this particular graph. And then what I do is I print the graph out to the user. And then I use that topological sort algorithm that I showed you on Wednesday. And so the topological sort uses a stack to keep track of the previously visited elements. Furthermore, the topological sort returned a unique graph. And then I'm going to print out the topologically sorted graph. And then what I'm going to do here is I'm going to run depth first search on the topological sort. And I have a new function, get num vertices, that I've put in. So let me do I'm trying to go to a line. Get num. Okay. And so because it's an adjacency list representation, all I need to do is return the result of the size function and return it as a long unsigned integer. And that will give me the total number of vertices. And so now what I'm going to do is I'm going to perform depth first search from each vertex, and that's going to tell me the path from course 0 to the final, to the course that I'm looking for. And so what I would like to do, Putty closed on me for some reason. What I would like to do is I'd like to show you the actual result. And what the result of this program is going to do is it's going to show me the original graph, and then it's going to show me the topologically sorted graph. So now I'm going to run make courses. Now it's going to run. And so here is the first test. This graph that's come out, this is the original graph that I've shown in the slide. And we see here that we wanted this edge 3, 1 gone, and that's why we chose depth first search as opposed to a breadth first search. Now, if we look at the topologically sorted graph, what we're going to see is 1 and 4 are still there. And we see that from vertex 1, we are able to get to 3. So now we've reduced the complexity of our flow and maintained the integrity of all of the prerequisites. So it's important in a course like this where you have some sort of ordering based on the vertices that depth first search is your preferred approach. And so now to test, let's compare the topological sort versus the result of all the depth first search. So we have, remember in class, I tested for this case where if we're trying to go from the origin to the origin, then it will catch that. And then I say from 0 to 1, we see that that's the case. Then from 0 to 2, it's like so. Then from 0 to 3, it's 0, 1, 3. So now we have this edge. From 0 to 4, just goes straight there. Valid path from 0 to 5 is 1, 3, and 5. 1, 2, and 6 is 6. And then 7 is 1, 2, 6, and 7. So there's our resulting graph. Now we see that there's no valid path from 0 to 8 or from 0 to 9. And we can check this by looking at the graph in the topologically sorted graph. And all we see there is 8 is an origin node vertex and 9 is a destination vertex. And so it's separate from the rest of the graph. And in this case, this is a desired result because now we can tell somebody who's planning a curriculum that 8 and 9 can't be reached based on how we have this set up. Should we require 0 to be a prerequisite for 8? Should one of these other ones be done? What would be the most efficient way to allow someone to be able to take those 2 classes in 4 years? So this is a very useful result for us. So let me show you the rest of the code here, and I have several other tests. Here I have a second graph where everything's connected, and we see that we have this initial graph, and we have it to everything. Here I have another graph, and as I mentioned on both Monday and Wednesday, I think it's really important when you're designing anything with vertices or any kind of data structures, you should be testing it for multiple types. So here we have a graph with a standard string. Here I have fun comp, systems, DS for data structures, theory of computing, and computer architecture. We have the actual prerequisites, and we see that it actually prints out the vertice location. And we have 0, fun comp, data structures, and then 4, if we go back here, 0 to data structures is required for computer architecture. And then here I'm actually using a character graph. We have A, B, C, D, E, and F. We have several edges there. And testing it out like before gives us our output. So we can do whatever type of representation we can use. We can print out the graph that way. We can represent the difference between the data and the actual vertex locations. And we can perform depth first search on a variety of graphs. So I have a comment in the chat. Okay. Okay, so before I move on to question 2, does anybody have any questions about the approach I took to solving that problem? Okay, so let's go to another, so topological sort, there's the resulting topologically sorted graph, and there's the output. All right, so here's the second one, and this is going to serve partially as a review, where we're going to deal with big O of n complexity. And Billy actually gave us a comment that alludes to what we are going to be wanting to do. So we were given an unsorted array of values, we need to find the length of the longest consecutive element sequence. So here's what this means. We have here an array of 6 elements, and we have 100, 4, 200, 1, 3, and 2. And so when we say consecutive elements, our solution should be 1, 2, 3, and 4. And so the result should be this length. So there's a couple things I want you to notice when you're first starting to approach this question. First, it says, given an unsorted array of values, it is not specific about the value type. And this becomes important when you're trying to figure out how to beat big O of n complexity. When people are approaching this type of problem, they get fixated on this idea of ints. And when they see ints and big O complexity, and I need to figure out the longest consecutive sequence, they think sorting. Okay, well, I have a lot of sorting, and I could potentially do counting sort or a bucket sort. And they see that, and that's big O of n. But what happens if I were to make these characters? Suddenly, it's not as so cut and dry to do that kind of sorting. So I think the next slide, I kind of, oh, yep. So brute force, just sort the elements in the array. And if it's not int, you might have to go into a merge sort or a quick sort to get big O of n log n. Then you would have to iterate through and keep track of the location and the longest value. And as I mentioned here, sorting others values other than integers makes counting sort or bucket sort prohibitive. Therefore, we would have to consider this n log n for sorting. So there's other ways to get around this. And when you're trying to meet big O of n on different types of values, you typically are like, okay, now I want to consider using a hash function. So the way I would approach this problem is we're actually going to hash all the elements from the array into a hash table, and then we're going to iterate through. And what's going to happen is we're actually going to check backwards and forwards by incrementing and decrementing. So for example, if I have 33, I'd say, well, is 32 in the hash? And if it is, we'll say, is 31 in the hash? And if it is, we'll say if 30 is in the hash, and if it's not, we'll then check 34 and 35. So this is where we say increment and decrement. Now here's a crucial part. What happens is after I find that 32 is in the hash, I'm now going to eliminate it. Likewise with 31 and with 34 and 35 there. And then after I've found that this is a length of 5, I'm going to eliminate that as well. So that way, when I come across 35 later through the array, I would say, well, I've already found a range that contains 35, and therefore, just decrementing again, if I would kept allowing myself to do that, that would cause this to become big O of n squared. So once we're going to do that, the largest value will be returned. So what I want to do is I want to show you an animation that goes through this full process. So first, I'm just going to say for simplicity, we just have a hash table of 11 elements. I'm not going to show any rehashing or double hashing or anything like that. We just want to keep the animation simple to focus on the actual hashing and approach to the solution. So first what I'm going to do is I'm just going to set all these values one by one into the hash. Then what's going to happen is over here on the right, I have my code. I'm going to show you what's going on here. I'm going to keep track of these values as we go through all of the tests. So first what I'm going to do is I have a templated num equals the array iter. And I'm going to start at iter is equal to 0, so that would be here. And I'll go through the array size, and then iter plus plus. And then the first thing I do is I check if this is contained in the hash. So at first, all of them are contained, but what you're going to see is we're going to start removing with lazy deletion elements from the hash to ensure that we can meet that big O event time. So once I do that, I'm now going to say T down is equal to num minus 1. So for example, I'm going to read, I've read in 36. 36 is the num, and 36 is contained in the hash. So we're now going to see down is equal to 35. There we go. I'm sorry. We're going to say down is equal to 35, which is 36 minus 1. And then we're going to check to see if that's in the hash. And we see that it is. And so this is that while loop that we're evaluating. So the first step is we are going to remove 35 from the hash. We're going to mark it as lazy deleted. Then I'm going to decrement down, which is going to move this to 34. So that will be the next value we check. And then count is going to be incremented. And so now we know the current local value for the longest sequence. So we're going to see that I'm going to decrement down by 1. First I remove 35 from the hash, then I decrement down by 1, and then I increment count by 2. So now I do the same thing. While count contains down. So we're evaluating here again. And so 34, as we're going to see, is in the hash. So that's going to be removed. We're going to remove 34, decrement down to 33, and then increment count to 3. Now we're going to check to see if 33 is in the hash. 33 is in the hash. So now we're going to see that we're going to remove 33 from the hash table, down to 32, and increment count to 4. So now again, 32 is in the hash. So now you're going to see that we're going to remove 32. This is going to become 31 and 5. Then we check to see if 31 is in the hash, and 31 is not in the hash. So then we break that while loop. See that down is not there. So after that while loop, we're now going to set a value up. That's equal to num plus 1. So this is going to be 36 plus 1, and this is going to be 37, which we're going to see is in the hash. So up is now 37. While count sort dot contains up, we're going to see we're going to remove 37 from the hash, increment up to 38, and then increment count to 6. Then we're going to check to see if 38 is in the hash. It is not. And so now we're going to break the while loop. Now the last thing we're going to do in this particular value is if count is greater than result, we're going to change count to result. Excuse me. And now we see that result is equal to 6. And now here's another thing that I do. Count sort dot remove num. This will ensure that I don't unintentionally try to evaluate 36 again. So now that we've removed it, we are now going to go back to the beginning of the for loop, and we are now going to evaluate 41. So let's walk through that step by step. And we're going to see that num is now equal to 41, and iter is now 1, and count is back to 1. We'll say if count sort contains num, and it does, we're now going to say T down is equal to num minus 1, which is 40, which is not in the hash. And then we go and look at T up. T up is going to be num plus 1, so that's going to be 42, which actually is in the hash. See, it's here. So now we're going to go through this process again. So we're going to increment up by 1, then we're going to increment count by 1, and then we're going to, we see that 42 is removed from the hash. So now we would go to 43. 43 is not in the hash. And then we move down to the if statement and we remove 41 from the hash. And now we're going to do the same process with 56. Down is 57. 57 is not in the hash. Then we move to up to check 58. 58 is also not in the hash. Count is less than result. And now we've removed 56 from the hash. So when we get to 3, this is where we get the big O of n. Notice how we've already evaluated 35, and now 35 is marked as lazy delete. So once we get here to if count sort contains num, it doesn't evaluate it. So then we go all the way, now we're at iter 4, 37 is marked as deleted, 33 is marked as deleted, 34 is marked as deleted. Now we have 92. Now we're going to set, well, down is 92 minus 1, so that was 91. 91 is not in the hash. So now we're going to check up at 93. 93 is not in the hash. And then we remove 92. And then we see that 42 is marked as deleted and 32 is marked as deleted. And now we have completed our algorithm. So to set everything up here, I have several different tests. So first, this is what I've done just to show you. I have a templated longest consecutive sequence. I call a dynamic array by reference. And then I create using that hash table that we developed in class. And then I insert using the standard pair. We go through all of the elements, put that into the hash table. And then here's the rest of the code that I showed you. And at the end, I return that final result value. And then in main, oh, I have a question in the chat. If the chat shows up, there we go. Sorry, I have to go to volleyball now. Ashley, have a good one. Not a problem. Happy to help. Hope this is very helpful.
Yeah, thank you.
Welcome. Okay, so, and we're almost done. I'm just going to walk through what the tests are. But now we have the original one from LeetCode. Then I developed another one with characters. And then I did another one with unsigned integers. And then I did another one with long unsigned integers. So we've done this throughout all of the for int, unsigned int, long unsigned int, and characters. And then I have the final test where this is the one that I presented that we have to test thoroughly in the final solution. So let me check to remind myself with longest con sequence. Make long con sequence. And then we see that it returns 4. We had 1, 2, 3, and 4, so it catches that appropriately. Here we have 5, and we have A, B, C, D, and E. Here we have 4, and we had 28, 29, 30, and 31. Here we have 3. Here we have 131, 132, and 133. And as we proved in the animation, this last one is 6. All right, so does anybody have any questions before I let you all go? All right, on that note, you all have a wonderful evening, and I will see you all tomorrow in class. You're welcome, Catherine. You're welcome, Chase.